back to Geometry Honors from the comfort of your own home. Before all the cancellations and before we were not in school, we were talking about solving triangles, and I want to review a few of those things before we get into anything new. So first off, we were talking about SOHCAHTOA, which was, there we go, which was short for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also had the Pythagorean theorem, a squared plus b squared equals c squared, but we said that each of those only worked for a special type of triangle. Those were only going to work for right triangles. If we didn't know explicitly that it was a right triangle, we had to come at it from a different angle. Get it? Angle? Anyway, we have other options. Okay, and these other options are the law of sines and the law of cosines. We'll get back to law of cosines later on. But first off, law of sines. Law of sines says for any triangle ABC. Now, this is important right here. Remember the way that we label the triangle. We label the vertices A, B, and C, and we use capital letters. We label the sides A, B, and C, and we use lowercase letters. And what's really important here is that the sides and angles that are opposite one another have the same letter for their name. Okay, they get the capital letter for this, the angles, and the lowercase letter for the sides, but they are opposite one another with the same letter. Now, for any triangle labeled as such, if you take side A and you divide it by the sine of angle A, that's going to be equal to the side B divided by the sine of angle B. But wait, there's more. That's also equal to that third side, C, divided by the sine of that angle, C. So the side divided by the sine of the opposite angle is going to be a consistent ratio. Those ratios are going to be equal for all three of those pairs. Now, one important detail to keep in mind here is in order to use this, you must have a pair of opposite measures. So we have to have side A and angle A, or side B and angle B, or side C and angle C, plus one other measure in order to use this law, in order to use this equation. So the real short thing that we can do, sketch the triangle, label the pieces that we have, and figure out what setup we have. Okay, remember we were talking about proving triangles congruent. We had side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, and leg, leg. Now, hypotenuse, leg, and leg, leg imply a right triangle. So if we have a right triangle, we can use SOHCAHTOA or Pythagorean theorem. But if we don't have those two, the options that this will work for are angle, side, angle, and angle, angle, side. Now, it also works for side, side, angle. That's the ambiguous case. We talked about that a little bit before break. Not break. Maybe we'll get back to that if we have time. Okay, but so we draw the triangle, we recognize the pieces that we have, and we determine if it's angle, side, angle, 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 side, or something else. If it's something else, we're going to skip law of cosines, excuse me, law of sines. We'll have to do something else. So let's take a look at these two triangles that we're given. Okay, we want to solve the triangle. Now remember, that means finding all the missing measures. So the first thing that I'm going to do is sketch a triangle. And it doesn't have to be super detailed. Okay, just label the sides and the vertices. There we go. Okay, so we have angle A is 37 degrees. Tell you what, here's what we're going to do. We're just going to highlight the pieces that we have. Okay, we have angle A, we have angle B, and we have side A. Okay, so what we have here, which setup are we looking at? Well, we have two angles and a side. So this side is not between those two angles. So that means that we're looking at angle, angle, side, which means law of sines is going to work. Now the next thing I'm going to do is set up my answer table. So my answer table is not super elaborate. I have the angle measures over here, and I'll have the side lengths over here. Okay, now angle A is 37 degrees. Let's just do this. Okay, angle B is 68 degrees. Okay, and angle C is as yet unknown. Okay, side A we have as 3, and the other two sides we still need to find. Now, the very first thing that we can find before anything else, we can use a really simple fact about triangles. We know that the sides of the angle measures have to sum to 180 degrees. So what we can do is take the two sides that we're given and subtract them from 180 degrees. So that means that the measure of angle C is going to be equal to 180 degrees minus the sum of the other two, 37 degrees and 68 degrees. Okay, so that's going to be the measure of angle C is equal to 180 degrees minus, that'll be 95, or excuse me, 105 degrees. Okay, and if we subtract those, that means the angle C is going to be equal to 75 degrees. Okay, so we can put that right here. All right, now we want to find side lengths B and C. So what we're going to do is we're going to come back to this law of sines. Okay, we're going to use A over sine of A equals B over sine of B equals C over sine of C. Now we're going to start with the ones that we're given, A over the sine of A. So we'll always start out with the formula. Anytime you're going to use a formula, write it down. So A over the sine of angle A is going to be equal to, I'll tell you what, let's find B first. So let's put B over the sine of B. Okay, now at this point what we can do is sub in what we have. So side A is 3 over the sine of angle A is 37 degrees. Okay, and that's going to be equal to our B, which is unknown, what we're looking for at this point, over the sine of angle B, which is 68 degrees. Okay, now what's this look like? This is a proportion, and we've worked with proportions in the past. The way that we solve proportions, we start by cross multiplying. Okay, and what we'll get is that 3 times the sine of 68 degrees is equal to our unknown B times the sine of 37 degrees. Now we want to get that B all the way by itself, totally isolated. So what we need to do is divide both sides by the sine of 37 degrees. Okay, over here, those signs cancel, and B is all by itself. Over here, well, now we need to use a calculator. So I'm going to come down here, maybe. There we go. And I will open my calculator app. So I need to take 3 times the sine of 68 degrees. Now what's really important here is before we press these sine, cosine, or tangent buttons, we need to make absolutely certain that we're in degree mode. So I'm going to press this button right here that says mode, okay, and I'm going to look right here. I have the option to be in radian or degree. And right now I'm in radian mode. Well, radian is a different way to measure angles. Okay, it's kind of like how you can measure distances in feet or meters. Okay, they're very, very different things, and the calculator can work with either one. So we need to make sure that we're in degree mode. Okay, now I want to go back to the calculator screen. So I press second, quit, and that takes me back to the home screen. Now, I want to do 3 times the sine of 68 degrees. Now it automatically opens up this set of parentheses, so right here I need to close that set of parentheses. And then I want to divide by the sine of 37 degrees. Okay, and I'll close those parentheses, and I'll go back up here and I'll take a look. Make sure I typed in everything correctly. 3 times the sine of 68 divided by the sine of 37. Okay, hit equals, and I get about 4.6. Now, guys, I know that I'm a big stickler for accuracy with your answers, not rounding. But when you're finding multiple measures like solving a triangle, it's okay to round it to 1 decimal place. In fact, that's the usual practice. So the length of side B, we're going to say is 4.6. Okay, so we'll put that right up here. .6 for side B. All right, now time to find side C. Okay, once we have these two, that's the only thing left to find. So we start out the exact same way. Okay, we'll say A over the sine of angle A equals C over the sine of angle C. Now, someone's going to say, could we use B over the sine of B here? Well, we could, but there's a couple of things. Number one, this was something that we found. And just in case we made a mistake, we don't want to use a wrong answer to find additional answers. So we're going to stick with the stuff that we've been given because we know that that's correct. Okay, we know that there's no mistake there. That's the given information. Additionally, we round it. Okay, we take a look at this, the answer on the calculator. It's not 4.6. It's 4.621937733. And even that, there's more decimal places after it. The calculator just can't display them. So we're not going to use this 4.6. We're going to stick with the information that we're given, and we're going to go from there. So we'll sub in the pieces that we have. Okay, so we have that side A is 3, angle A is 37. Okay, side C is what we're looking for, and we'll put that over the sine of angle C, which is 75 degrees. Okay, and then we go from there. We keep on moving. So we have a proportion, and the way that we solve proportions is we cross multiply. So I'll have C times the sine 37 degrees is equal to 3 times the sine of 75 degrees. Okay, and now we want to get that C all the way by itself. So we're going to divide both sides by the sine of 37 degrees. Okay, and over here, those signs are going to cancel. Oh, nope, that's not true. Over here, those signs are going to cancel. Okay, and I'll get C all by itself. Okay, what we need to do now is come over to that calculator. So I'll take out my Webbit Emu. Okay, and I will do 3 times the sine of 75 degrees, close it, divided by the sine of 37 degrees. Close those parentheses. Now go back and double check, make sure everything's exactly what we want. Okay, 3 times the sine of 75 divided by the sine of 37 equals, and we get about 4.8 for that third side. Okay, so we can put that right in here, 4.8, and then we can come up here to our answer table, and we can say that side C is equal to about 4.8. Okay, and there we go. Now, here's something that we can keep in mind. We talked about this a while back. We said that the largest side of a triangle has to be opposite the largest angle. The smallest side has to be opposite the smallest angle. So let's take a look at those. The largest side here is 4.8, and that's opposite the largest angle of 75 degrees. So that checks out. Okay, the smallest side is 3, which is opposite the smallest angle of 37 degrees. Now, guys, this won't guarantee that your answer is correct, but it'll help you to find major mistakes if there are any. So you can check this way. It's not going to guarantee that you're right, but it's going to help make sure. Okay. All right. So I'll save this number 2. Put another video of that later on. Right now, let's just take a look again at the law of sines. It says that if you have a triangle ABC where the sides are labeled with the same letter that the angle they are opposite, side A over sine of angle A is equal to side B over the sine of angle B is equal to side C over the sine of angle C. And we can use that to find any missing measures on any triangle as long as we have at least one pair of opposite measures. So the shortcut is this works for angle side angle, angle angle side. It also works for side side angle, but we're going to take a step away from that right now. Okay, also look on Teams. There's going to be an assignment posted for you guys called Law of Sines Worksheet, a couple of triangles that you need to solve. And additionally, there will be a very short quiz on Friday, just a couple of triangles you need to find some missing measures on. All right? Have a good one, guys. Take care. Email me if you have any questions, and I'll talk to you then.